It is likely that the shed is a hazardous location. Gasoline vapors are heavier than air and can accumulate near the floor, creating an explosive atmosphere. NFPA 70, which is the National Electrical Code, Article 500, covers hazardous locations and the requirements for electrical installations in these areas. NFPA 30, which is the Flammable and Combustible Liquids Code, Article 5, addresses storage and handling of flammable liquids, including gasoline. Considering requirements for electrical installations in hazardous locations. Firstly, classification. The shed would likely be classified as a Class 1, Division 2 hazardous location. Secondly, wiring methods. Electrical wiring must use explosion-proof or intrinsically safe methods. Thirdly, conduit. Conduit must be sealed at all openings. Fourthly, receptacles and switches. Receptacles and switches must be explosion-proof or intrinsically safe. Fifthly, lighting fixtures. Lighting fixtures must be explosion-proof or intrinsically safe. On the topic of legal ramifications, electrical installations in hazardous locations must comply with all applicable codes and regulations. Non-compliance can result in fines, legal liability, and insurance issues. Recommendations include: firstly, review the installation with a qualified electrician to ensure it meets code requirements. Secondly, install a ventilation system to remove gas vapors. Thirdly, consider replacing the drywall ceiling with an approved fire-rated material. Fourthly, train employees on the hazards of gas vapors and proper storage practices. The safety inspector's approval does not guarantee compliance with code requirements. It is ultimately the responsibility of the installer to ensure that the installation is safe and code compliant. Article 500 of the National Electrical Code, (NEC), covers the general requirements for electrical equipment and wiring in hazardous locations. It outlines the different classes, divisions, and groups of hazardous locations, as well as the types of protection techniques that are permitted in each location. Some key sections include: firstly, 500.4 covers the general requirements for equipment. Secondly, 500.5 covers the classification of locations. Thirdly, 500.7 covers the methods for maintaining the area classification. Fourthly, 500.8 covers the requirements for equipment marking. Article 501 specifically addresses Class 1 hazardous locations, which are areas where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Some key sections include: firstly, 501.10 covers wiring methods. Secondly, 501.15 covers sealing requirements. Thirdly, 501.125 covers luminaires, that is, lighting fixtures. Fourthly, 501.130 covers receptacles and attachment plugs. Article 505 covers zone classifications for Class 1 hazardous locations. This provides an alternative classification system to the division system, using Zones 0, 1, and 2 to define the likelihood of flammable gases or vapors being present. Article 511 addresses commercial garages, repair, and storage areas, which may be relevant if the shed is used for vehicle maintenance. Some key sections include: firstly, 511.3 covers classification of locations. Secondly, 511.4 covers wiring and equipment above hazardous locations. Thirdly, 511.7 covers equipment within hazardous locations. Article 513 covers aircraft hangars, which provides requirements for electrical installations in areas where aircraft are stored or serviced. Some key sections include: firstly, 513.3 covers classification of locations. Secondly, 513.4 covers wiring and equipment in hazardous locations. Thirdly, 513.10 covers equipment not within hazardous locations. Article 514 addresses gasoline dispensing and service stations, which may be relevant if fuel is stored or dispensed in the shed. Some key sections include: firstly, 514.3 covers classification of locations. Secondly, 514.8 covers circuit disconnecting means. Thirdly, 514.11 covers wiring methods. Article 515 covers bulk storage plants, which may be relevant if large quantities of flammable liquids are stored in the shed. Some key sections include firstly, 515.3 covers classification of locations. Secondly, 515.4 covers wiring and equipment within hazardous locations. Thirdly, 515.16 covers grounding. Article 516 covers finishing processes, which addresses areas where flammable or combustible liquids are used for painting, coating, or similar processes. Some key sections include firstly, 516.3 covers classification of locations. Secondly, 516.4 covers wiring and equipment in hazardous locations. Thirdly, 516.5 covers grounding. Within Class 1 locations, Division 1 is a location firstly, in which ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors can exist under normal operating conditions. Secondly, in which ignitable concentrations of such hazards may exist frequently because of repair or maintenance operations or because of leakage. Thirdly, in which breakdown or faulty operation of equipment or processes might release ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors, and might also cause simultaneous failure of electrical equipment in such a way that it could become a source of ignition. Division 2 is a location firstly, in which ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors are not likely to exist under normal operating conditions. Secondly, in which ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilation equipment. Thirdly, that is adjacent to a Class 1, Division 1 location, and to which ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. Some examples of protection techniques acceptable for Class 1, Division 1 locations are firstly, explosion-proof equipment. Secondly, intrinsically safe systems. Thirdly, purged and pressurized systems. Fourthly, non-incendive equipment. Fifthly, oil immersion. Sixthly, hermetically sealed equipment. Some examples of protection techniques acceptable for Class 1, Division 2 locations are firstly, explosion-proof equipment. Secondly, intrinsically safe systems. Thirdly, purged and pressurized systems. Fourthly, non-incendive equipment. Fifthly, oil immersion. Sixthly, hermetically sealed equipment. Seventhly, non-sparking equipment. Eighthly, Type C pressurization. When selecting equipment for hazardous locations, several factors must be considered. Firstly, the class, division, and group of the hazardous location. Secondly, the operating temperature of the equipment. Thirdly, the environmental conditions such as temperature, humidity, and corrosive substances. Fourthly, the specific requirements of the application. To ensure safety, electrical equipment in hazardous locations must be properly installed and maintained. Some key steps include firstly, using qualified personnel for installation and maintenance. Secondly, following manufacturer's instructions. Thirdly, conducting regular inspections. Fourthly, implementing a preventative maintenance program. Ventilation systems play a crucial role in diluting and removing flammable vapors from hazardous locations. Some key considerations include firstly, designing the ventilation system to provide adequate airflow. Secondly, ensuring the ventilation system is properly maintained. Thirdly, using explosion-proof ventilation equipment. Grounding and bonding are essential for preventing the accumulation of static electricity, which can be a source of ignition. Some key steps include firstly, properly grounding all electrical equipment. Secondly, bonding all metal parts together. Thirdly, using static grounding straps where necessary. Regular inspections and testing are necessary to ensure that electrical equipment in hazardous locations is operating safely and in accordance with code requirements. Some key steps include firstly, conducting visual inspections. Secondly, performing electrical tests. Thirdly, documenting inspection and test results. Employees working in hazardous locations must be properly trained on the hazards of flammable materials and the safe operation of electrical equipment. Some key elements of training include firstly, hazard awareness. Secondly, safe work practices. Thirdly, emergency procedures. In addition to the NEC, other codes and standards may apply to electrical installations in hazardous locations. These may include firstly, NFPA 30, Flammable and Combustible Liquids Code. Secondly, API Recommended Practice 500, Classification of Locations for Electrical Installations at Petroleum Facilities. Thirdly, ISA Standards for Instrumentation in Hazardous Locations. A qualified electrical engineer or inspector can provide guidance on the specific requirements for electrical installations in hazardous locations. They can assist with firstly, classification of locations. Secondly, selection of appropriate equipment. Thirdly, design of electrical systems. Fourthly, inspections and testing. Proper documentation is essential for demonstrating compliance with code requirements and ensuring the safety of electrical installations in hazardous locations. Some key documents include firstly, area classification drawings. Secondly, equipment specifications. Thirdly, installation records. Fourthly, inspection and test reports. Maintaining a safe electrical installation in a hazardous location is an ongoing process that requires vigilance and attention to detail. By following the recommendations outlined in this discussion and consulting with qualified professionals, one can minimize the risk of fire and explosion. Article 500.2 defines the terms used in Article 500 to promote consistent interpretation and application of the requirements. The terms are specific to hazardous locations and are essential for understanding the scope and intent of the code. Some key definitions include approved, dust ignition proof, explosion proof equipment, intrinsically safe circuit, intrinsically safe equipment, and purged and pressurized. Article 500.3 discusses other considerations for hazardous locations beyond the specific requirements in Article 500. These considerations include firstly, potential chemical effects. Secondly, presence of flammable dust or fibers. Thirdly, proper maintenance. Article 500.4 covers the general equipment requirements for all hazardous locations. The equipment must be firstly, approved for the specific hazardous location. Secondly, marked with the class, division, or zone and group. Thirdly, installed according to its listing and labeling. Article 500.5 provides the classification of hazardous locations based on the properties of the flammable materials that may be present and the likelihood of those materials being present in ignitable concentrations. There are three classes: Class 1, Class 2, and Class 3, 2 divisions, Division 1 and Division 2, and several groups. Article 500.6 covers the requirements for the area classification, including firstly, documentation. Secondly, periodic review. Thirdly, qualified personnel. Article 500.7 covers the methods for maintaining the area classification, including firstly, ventilation. Secondly, inerting. Thirdly, dust collection. Article 500.8 covers the requirements for equipment marking, including firstly, the manufacturer's name. Secondly, the model number. Thirdly, the hazardous location designation. Article 500.9 covers the wiring methods permitted in hazardous locations. The wiring methods must be appropriate for the class, division, or zone and group. Some common wiring methods include firstly, rigid metal conduit. Secondly, electrical metallic tubing with threaded fittings. Thirdly, cable with a gas-tight continuous sheath. Article 500.10 covers the sealing requirements for conduit and cable systems in hazardous locations. Sealing is required to prevent the passage of gases, vapors, or dust from one area to another. Some key requirements include firstly, seals must be installed at the boundaries of hazardous locations. Secondly, seals must be listed for the intended purpose. Thirdly, seals must be accessible for inspection and maintenance. Article 500.11 covers the grounding and bonding requirements for electrical equipment in hazardous locations. Proper grounding and bonding are essential for preventing the accumulation of static electricity and providing a path for fault current to flow back to the source. Some key requirements include: firstly, all metal equipment enclosures must be grounded. Secondly, bonding jumpers must be used to connect metal parts together. Thirdly, grounding electrodes must be installed in accordance with Article 250. Article 500.12 covers the surge protection requirements for electrical equipment in hazardous locations. Surge protection is required to protect sensitive electronic equipment from damage caused by voltage surges. Article 500.13 covers the control equipment requirements for electrical equipment in hazardous locations. Control equipment must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, control equipment must be located outside of hazardous locations. Secondly, control equipment must be intrinsically safe or explosion-proof. Thirdly, control equipment must be interlocked with safety devices. Article 500.14 covers the specific requirements for lighting fixtures in hazardous locations. Lighting fixtures must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, lighting fixtures must be explosion-proof or intrinsically safe. Secondly, lighting fixtures must be marked with the class, division, or zone and group. Thirdly, lighting fixtures must be installed with proper clearances from flammable materials. Article 500.15 covers the specific requirements for motors and generators in hazardous locations. Motors and generators must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, motors and generators must be explosion-proof or intrinsically safe. Secondly, motors and generators must be marked with the class, division, or zone and group. Thirdly, motors and generators must be installed with proper overload protection. Article 500.16 covers the specific requirements for transformers in hazardous locations. Transformers must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, transformers must be explosion-proof or intrinsically safe. Secondly, transformers must be marked with the class, division, or zone and group. Thirdly, transformers must be installed with proper overcurrent protection. Article 500.17 covers the specific requirements for heating equipment in hazardous locations. Heating equipment must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, heating equipment must be explosion-proof or intrinsically safe. Secondly, heating equipment must be marked with a class, division, or zone and group. Thirdly, heating equipment must be installed with proper temperature controls. Article 500.18 covers the specific requirements for instrumentation in hazardous locations. Instrumentation must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, instrumentation must be intrinsically safe or explosion-proof. Secondly, instrumentation must be marked with a class, division, or zone and group. Thirdly, instrumentation must be installed with proper barriers and seals. Article 500.19 covers the specific requirements for flexible cords in hazardous locations. Flexible cords are permitted in hazardous locations only under certain conditions. Some key requirements include: firstly, flexible cords must be extra hard usage type. Secondly, flexible cords must be connected to explosion-proof or intrinsically safe equipment. Thirdly, flexible cords must be protected from physical damage. Article 500.20 covers the specific requirements for receptacles and attachment plugs in hazardous locations. Receptacles and attachment plugs must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, receptacles and attachment plugs must be explosion-proof or intrinsically safe. Secondly, receptacles and attachment plugs must be marked with the class, division, or zone and group. Thirdly, receptacles and attachment plugs must be installed with proper seals. Article 500.21 covers the specific requirements for capacitors in hazardous locations. Capacitors must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, capacitors must be explosion-proof or intrinsically safe. Secondly, capacitors must be marked with the class, division, or zone and group. Thirdly, capacitors must be installed with proper overcurrent protection. Article 500.22 covers the specific requirements for control circuits in hazardous locations. Control circuits must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, control circuits must be intrinsically safe or explosion-proof. Secondly, control circuits must be marked with the class, division, or zone and group. Thirdly, control circuits must be installed with proper barriers and seals. Article 500.23 covers the specific requirements for signaling, alarm, and communication systems in hazardous locations. Signaling, alarm, and communication systems must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, signaling, alarm, and communication systems must be intrinsically safe or explosion-proof. Secondly, signaling, alarm, and communication systems must be marked with the class, division, or zone and group. Thirdly, signaling, alarm, and communication systems must be installed with proper barriers and seals. Article 500.24 covers the specific requirements for storage battery systems in hazardous locations. Storage battery systems must be designed and installed to prevent the ignition of flammable materials. Some key requirements include: firstly, storage battery systems must be explosion-proof or intrinsically safe. Secondly, storage battery systems must be marked with the class, division, or zone and group. Thirdly, storage battery systems must be installed with proper ventilation. The purpose of explosion-proof equipment is to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. Explosion-proof equipment is designed to withstand the pressure of an internal explosion and to cool the hot gases escaping from the enclosure to a temperature below the ignition temperature of the surrounding atmosphere. Intrinsically safe equipment is designed to limit the energy available in electrical circuits to a level that is below the ignition energy of the surrounding atmosphere. Intrinsically safe equipment is used in hazardous locations where the risk of explosion is high and where it is not practical to use explosion-proof equipment. Purged and pressurized equipment is designed to prevent the entry of flammable gases, vapors, or dust into an enclosure by maintaining a positive pressure inside the enclosure with a clean, dry, inert gas or air. Purged and pressurized equipment is used in hazardous locations where it is necessary to protect sensitive electronic equipment from damage caused by flammable materials. Non-incentive equipment is designed to not generate sparks or hot surfaces that could ignite flammable materials. Non-incentive equipment is used in Class 1, Division 2 and Class 2. Division 2 hazardous locations where the risk of explosion is lower than in Division 1 locations. Oil immersion is a protection technique in which electrical equipment is immersed in oil to prevent the ignition of flammable materials. Oil immersion is used in hazardous locations where it is necessary to protect high-voltage equipment from damage caused by flammable materials. Hermetically sealed equipment is designed to prevent the entry of flammable gases, vapors, or dusts into an enclosure by sealing the enclosure with a gas-tight seal. Hermetically sealed equipment is used in hazardous locations where it is necessary to protect sensitive electronic equipment from damage caused by flammable materials. Non-sparking equipment is designed to not generate sparks that could ignite flammable materials. Non-sparking equipment is used in Class 1, Division 2 and Class 2, Division 2 hazardous locations where the risk of explosion is lower than in Division 1 locations. Type Z pressurization is a type of pressurization in which the pressure inside the enclosure is maintained at a level that is slightly above the pressure outside the enclosure. Type Z pressurization is used in hazardous locations where it is necessary to protect sensitive electronic equipment from damage caused by flammable materials. The authority having jurisdiction, or OJ, is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation, or a procedure.